Hello and welcome to the Certified BIM Specialist Road and Highway Solution Exam Preparation class. My name is Michelle Rasmussen. I'm with Ascent and I'm here today to help you prepare for your exam. Before we get too far, let me just tell you a little bit more about me. I've been using the AutoCAD product since Release 9 and teaching it since 2000. I've been writing courseware for Autodesk and Ascent since 2007 and recording content for e-learning since 2005. I also started teaching synchronous classes, meaning live classes online, in 2007, but not only do I teach online, I also completed my degree online when I completed my master's degree in business. Just to summarize the class, we're going to show your employer, colleagues, and clients that you are serious about being proficient in the full suite of tools that you use for your job on a daily basis. Getting certified on Autodesk software can help you improve productivity, enhance your credibility, and accelerate your professional development. This class will help you prepare for the Autodesk Infrastructure Design Suite Roads and Highways Workflow Certification exam. You'll learn about the specific exam objectives and how to use the software to answer the questions related to the questions quickly and correctly to ensure your success as you take the exam. Key learning objectives include sketching layouts and creating engineered roads of the proposed design in Autodesk InfraWorks, then taking that design into AutoCAD Civil 3D and using it to create the detailed drawings, and analyzing the design using both Autodesk InfraWorks and Autodesk Navisworks Manage. Then we'll communicate the design visually using Autodesk InfraWorks. The Autodesk Infrastructure Design Suite is a combination of powerful Building Information Modeling software, or BIM software. And it streamlines the workflow of infrastructure projects with a 3D model while reducing conflicts and changes during construction, reducing rework, producing better project outcomes, and improving productivity. This class takes you through an optimized workflow, as you see described here, for a road and highway design project using the Autodesk Infrastructure Design Suite. We start off in the project planning phase, where we'll define the project extents, establish existing conditions, create and analyze some conceptual design options, and select the best conceptual design to move forward into the preliminary design. Then we'll design the horizontal and vertical alignment of the selected design and add design constraints to the selected design. So things like your curve radius and your tangent lengths and design speed for that road. Then we'll enter design values and costing information to ensure budget constraints are met. Doing this, we'll actually balance our cut and fill using the optimization tools inside of InfraWorks and InfraWorks 360. Then we'll take the design into Civil 3D, where we'll work on the detailed design. We'll design typical cross-sections of the road design, create finished ground contours, perform cut and fill analysis, and create a mass haul diagram, as well as perform some clash detections inside of Autodesk Navisworks Manage. Finally, we'll create some still images and renderings of key parts of the design to communicate what it will look like to the stakeholders. We'll also create some animations of the new design to show traffic flow. Since we are preparing for the certification exam, during the project planning phase, it might be helpful to see some of the objectives. Those objectives almost exclusively refer to the Autodesk InfraWorks software, where we're going to use the navigation tools to navigate the model, take a look at the interface, select project extents, set a coordinate system, start drawing, and using those road tools. So let's just jump right into it and see what it's all about. The first thing you want to be able to do in Autodesk InfraWorks is be able to navigate the models that you'll be working with. Typically you'll use the mouse for this, but using the mouse in Autodesk InfraWorks is slightly different than using it in the CAD-based programs like AutoCAD Civil 3D. So when you hold your left mouse button down and move the mouse around, you'll actually do a 3D orbit to look at that model in 3 dimensions. Using the right mouse button, you'll be able to pan around in the drawing, And then using your mouse wheel, you'll be able to zoom in and zoom out. Another great tool is the Look At tool. And when you choose that, you'll be able to zoom in on a selected point or selected object. Other things that you might use are things like the View Cube, which is very similar to the View Cube that you'll find in AutoCAD or AutoCAD Civil 3D. And last thing is you can use actually bookmarks, which are like saved views in AutoCAD. You'll find the bookmarks on the Home tab under the Location Bookmarks panel. Let's take a look at it in the software. Now that I'm in Autodesk InfraWorks, I can look around my model. When I left click and drag my mouse, it does pivot the model to do a 3D orbit. And moving the mouse away from me, it looks as if I'm walking into the model. Moving it toward me as if I'm backing up out of the model. And then to pan around, I hold that right mouse button down and move it. If I want to look at a specific object, I can go to the tool strip on the left and choose the Look At tool, and then simply pick an object in my model, and it will zoom me right into that specific object. Now, if I'd like to go back to a home view or a view that's saved as home, I can go over here to my View Cube and choose any of my predefined views by clicking on any part of that View Cube, or if I click on the Home button right there, that is going to take me right back out to the home view that has been saved. If I want to change the view that has been saved as my home, I simply zoom in where I want, right-click on the View Cube, and choose Set Current View as Home. Now the other option that I have is I can actually use bookmarks to go back and forth between locations. If I happen to have a bookmark that's saved, I go to the Home tab, click on the bookmarks, and then choose any of the bookmarks or 3D views that have been predefined. If I need to add a new bookmark, maybe I want to zoom in on my governor's mansion that is sitting over here at the waterfront, I set the view first, then I choose Add Bookmark, and I name the bookmark and click OK. Next time I want to move between the views, I can do it quickly and easily with that Bookmark tool. Now that you know how to navigate, you need to learn how to use the interface to create a new model. To create a new model, you'll just go to the Application menu and choose New, or choose New from the Quick Start dialog box. Then you'll be introduced to the dialog box that you see on the screen here. The first shot on the left actually shows the typical settings. You can set the location, where you want it to save, the name of the file, and a description, but you can also set the model extents right from the get-go. It's not always typical that you know the model extents right away, so you can leave that blank until you figure out what your model extents are. Then you'll go to the advanced settings to actually define the coordinate system. Now, coordinate systems are extremely important because they allow you to have the computer automatically reproject the data even if it's in different coordinate systems. So for instance, here in Utah, most of the organizations will use the state plane coordinate system, but sometimes we'll get something in lat and long. It's no problem if you're using the Autodesk software because there are several projection systems already available in the Autodesk software, and by setting the project coordinate system and having that coordinate system defined in the drawings you attach or the GIS data that you attach, the software will automatically reproject things, do that mathematical equation to change the origin, the scale, all of it, to set everything right on top of each other where it should be. If for some reason you need to change the model extents or set the extents after you've already started a model, or even set the project coordinate system, you can do that by going to the Application menu and choosing the model settings, and you'll get a dialog box similar to the one you had when you created a model. Then of course you'll also want to configure the default units for the project. Setting the projection system does not set the model units. So to set that, you go to the Application menu and choose Options, and under the unit configuration, you'll set the default units to either metric or imperial. So let's see it in the software. If you're already in another model, to create a new model, you'll simply go to the Application menu and select New. Then, in the New dialog box, you'll give it a name and a description. Then you'll set the model extents. By checkmarking that option, you'll be able to set the minimum and maximum X and Y values. You can also load those from an external file if you have it. I'm not going to set mine yet because I want to show you how to set that after the fact as well. But you do want to make sure that you go into the advanced settings every time and set the coordinate system. If you use the down arrow next to the globe, you'll see a list of previously used coordinate systems. If I use the globe next to it, I'll have the option of going and finding where the category is at, and then select a code within that category. So these are locations all around the world, and within there you'll be able to find specific locations and specific coordinate zones, whether you're using US foot meters or whatnot. Now, even though you have selected a specific coordinate system, it does not set the units. So you need to make sure that you understand how to set the units. So now that the new model is set, I can go back in and set the limits of my file, or I can set the units. By going to the Application menu, I can select the model settings to change the coordinate system that is being used, and rather than use the entire model, I can set those X and Y values for the minimum and maximum values. Then to change the units, I go back to the Application menu and choose Options, and under the unit conversion, I decide whether or not I'm using metric units or imperial units. And now you're ready to start modeling. Once you start a new model, the Data Sources panel will appear, and in that panel you can actually apply two different types of data sources. You can do file data sources, which are your 3D models, your shape files, raster images, stuff like that, or you can do database source files. So that would be your MySQLs, SQL Server Spatials, and stuff like that. However, once you insert the data, they don't appear until you actually configure them. So things that you'll have to configure would be the type, whether or not you want to map fields. For instance, you might want to map the height of a building to a specific field that will set the height of those footprints to show the buildings in 3D. The other things you can set is the coordinate system that the source file is coming from, not the coordinate system of your model, but the source file itself. And then you can decide if you want to set the elevation of those items, especially if you have pipes, or if you want to take your buildings and drape them on a surface and have them appear like they would in the real world. Let's take a look at it in the software. Once you have a new model, this Data Sources panel will appear. However, if you close it, or if you need to go in to add more data, on the Home tab in the Import panel, you'll choose Data Sources. The Database Data Sources is the cylinder with the plus symbol, and the File Data Sources is the sheet of paper with the plus symbol. From this, you'll choose the type of data that you have. If I happen to have an SQLite file with my roads in it, I can choose that, select my road file, and you'll notice nothing appeared. That's because you do have to make sure you configure it. So to configure it, you simply double click on it in the drawing. You'll choose the type of file that you're working with. Mine happens to be roads. And you need to make sure at the very least that you set the geographic location. Mine actually read the projection file, the PRJ file that's associated with it, so it knew that it's from the national grid. On the Source tab, if I had a surface in this file already, or a DEM, or some kind of raster file that defined this existing ground, I could tell it to drape it across that existing ground, or I can set elevations manually. Or I can set it to not drape. On the Common tab, you have the option to set style rules, which we'll talk about later, and map any fields that you might have. Once you have done all of this, you'll just make sure that you can see the close and refresh, and you'll click it, and it will display in the model. You'll find that Autodesk InfoWorks is very much about style, and in fact, when you want to set the way an item looks from the data sources, you can do that in a couple of different ways. One, you can set style rules that allow you to use the data behind the data source to actually set the display of the data source. So for instance, a road class could be defined in the database behind the software, and you can use that road class to decide if you're showing it as a freeway or a local road. The other option is to actually override a style by dragging and dropping a style from the style dialog box. Another way to emphasize a road is to actually draw a portion of an existing road by tracing it using the road layout tools. In order to draw a road using the Create Roads tools, you first need to access them. First, you have to go to the tool strip and use the Create and Edit Features option. Then that will open up the draw strip, and on the draw strip you'll choose the Create Roads, making sure that you choose the right option because you have both Create Roads and Design Roads. The difference with the Create Roads is it allows you to see things in a 2D view as shown in the image on the left, as well as in a 3D model as shown in the image on the right. Once you select the Create Roads, you can select it a second time to select a road style to draw with. I typically like to set the style up first and then start drawing. If I forget to do that, I can always come back and change the style. Let's start off with setting a style for the existing roads. As I mentioned before, you can actually set some style rules. On the Home tab, Stylize Model, you'll see that you have style rules. If I click on that, it brings up a palette that will allow me to stylize my roads according to a speed or any other number of properties behind the roads. You can see that I have a highway here, a 2-lane highway, and then a local road with some street lamps and sidewalks. This was stylized by using the style rules. You can see my styles are set here on roads. I do need to make sure I'm on the roads tab, and then I can add another style if I need to by hitting the plus symbol, giving it a name, and click OK. Then I need to define what that style uses. So I'll come up here to the pencil and I'll choose Edit, and I can choose a property behind the road to say what's my maximum speed. So I need to make sure that my maximum speed is greater than maybe 50 miles per hour. If I don't know what that value is, I can go and get values and choose it from the list and get the values from there. I know that 50 is going to work for me. I click OK. Then I need to tell it what style to actually use. So I'll click Add Style, and maybe I want a divided highway for those. When I click OK and refresh my model, all of my roads that have a maximum speed of greater than 50 miles per hour will update. You can see also that I can do this for any number of coverages. For instance, buildings is set up so that I have single family, multifamily, businesses, offices, and so on. And by setting those up, when I go out into my model, you'll see that my businesses have different face fronts according to what height they are. We've learned how to set a style according to a rule. But what if we have a style that is unique? Maybe it doesn't match the guidelines. It's a 50-mile-an-hour road, but it's a divided highway, or maybe it's a local road, but it's going to be a divided highway. So for instance, I can come up here and you can see this road isn't matching this highway. I can choose to change that by going to the Style palette and finding my road styles, click Road, and then I have two options. I have my street or my interstate, and when I choose one of them, I can then just drag and drop the style that I need right on top of the road in question. But what about these areas where it looks like in the image that I have a road, but there's no road physically there, meaning it's not part of the coverage? Well, I can actually trace that by choosing the Create Edit Features on the tool strip, which brings up our draw strip. Then on the draw strip, I'll choose Create Roads. When I left click on that slowly twice, It gives me the option to choose any of the styles that have been previously used, or I can select a specific style from the Select Style option. Brings up that Style dialog box again, and then I can choose the style that I need, click OK, and when I come out and start left-clicking to draw that road, it puts in the style that I've selected. Once the road is drawn in the plan view, you can go back and adjust both the horizontal and the vertical layout of the road. You do this by either adding and removing vertices or using the gizmos to adjust what you have. So using the gizmo in plan view, you can rotate the road, use a control point to adjust the length of a certain segment of the road. You can actually use the move option or the move gizmo to move the entire road. And if you turn your view to 45 degrees or greater, so that you're looking at more of an elevational view, then you can change the height of the road and the elevation of specific control points. You can also split a feature, which we'll talk a little bit more about when we talk about changing the style of just part of the road. Last but not least is you can actually change the road properties by going into the Properties dialog box and changing the style or changing the number of lanes that you see, and then clicking the Update inside of Properties to actually view it. Now, you can actually change part of the road to show a structural object by doing a split. So when you have a sketched road, you can right-click on a certain part of it and choose Split, and that will split the road at that point. Then you can select only one part to change the style, either by dragging the style across onto the model or going into the road properties and changing it that way. Let's take a look at this in the software. When I select a road in the plan view that has been drawn with the Create Roads tool, you'll notice that I do get the gizmos. This gizmo here allows me to move it. Any of the purple control points allow me to adjust where that road ends or where the curve starts. And if I take a look at it from a side view using my left mouse to orbit the drawing, you'll notice that those grips become elevational grips. So I can choose to change the elevation of any one of these points. One thing you'll notice though is that the grips are only at the horizontal points of intersection. I cannot add additional grips with the Create Road tool when I'm adjusting a road that was created with Create Roads. What I can do though is I can right-click at a specific spot and I can choose the Split feature option. This will break the road up into two distinct pieces. I can do the same thing on the other side. I can right-click here and choose the Split feature, and that will break it up into three pieces. Now I can choose the middle piece, right-click, and go into its properties to change the style manually to a bridge style. To make it take, if I use the properties, I do have to choose Update, and then it will adjust. During the preliminary design, you may also want to apply some visual effects so that you can figure out if shadows are going to affect your design. For instance, in Utah, ice on the roads might be a concern, especially if you're building bridges. And so being able to cast shadows across a bridge is very helpful. Being able to see how the shadows adjust throughout the year or throughout the day even will allow you to decide if that is the best place to locate a road or a bridge. And then another option you might want to try is actually running a line of sight study. To do this, you select the Visible tool on the Analyze tab line of sight panel, and from any point of view it will actually select everything that is visible from that point of view. This is really great, especially if you need to show how things will look from the backyard of a stakeholder or from a public location that people are concerned about. In looking at this bridge, it doesn't look like there's going to be any kind of a problem until I realize how much vertical elevation change there is from the top of the bridge down to where it's going to turn into the other road. So I may want to actually do a shadow study to make sure if I have ice in the area that shadows are not going to create additional ice that becomes a problem. To do that shadow study, I go to the Visual Effects tab and then turn on my shadows and ambient occlusion. With both of those off, you can see I don't see any shadows at all. The ambient occlusion, though, is a reflection from one surface to another. Then I will set the sky and sun settings. I can set the wind speed, the wind direction, how much cloud coverage I expect to have. Maybe we're in Seattle and there's a lot of rain. It just depends on where you are. Then I can choose to set the date. You'll notice that as I slide the date, you'll see the change in the seasons. The other option I have is I can change the time of day. We want to make sure that during rush hour we don't have shadow problems on the buildings. So going back to early morning, oops, now that I see that in the early morning, during the early morning rush hour, I may want to change my mind on where I place that bridge. The other option I have is I can go and see what my line of sight is. Maybe from the governor's mansion here, I want to make sure that I don't see too much of that bridge. So I'm just going to make it look as though I'm standing in front of the governor's mansion. There we go. And I'm going to find out if the trees will mask enough of that bridge or not. To do that, I want to go to the Analyze tab this time, and then on the Line of Sight panel, I select Visible. It's going to go and select all the buildings, trees, bridges, anything that it can see that is in that line of sight. Now that we've completed the project planning part of the workflow, we're going to move into the preliminary design. There are 11 objectives in the preliminary design part of the test. We'll create a new project proposal, draw new versions of the road layout using layout tools, modify the horizontal layout, modify the profile using vertical road layout tools, enter design values and costing information, enter financial parameters for that optimization, and then run a vertical optimization for relevant project constraints. Next, you'll select the optimum proposal based on numerical analysis and create a storyboard to help you analyze it. You'll analyze the model using visual analysis tools and export it into AutoCAD Civil 3D. Now that the project planning is done and all the existing conditions are visible, it's time to create a proposal. Proposals provide multiple design options. We start with the master proposal, which is the base model with all the existing conditions in it. Then we add a new proposal, and anything that is in the proposal you start with will be merged into the new proposal. To access proposals, you go to the Home tab on the Design panel. To access proposals, you go to the Home tab and then the Design panel and click Proposals. This opens up the proposal panel. Remember, the master proposal is your base model. It has all your existing conditions in it. When you're ready to start adding design options, you click the plus symbol, and it's going to copy everything that was in that master proposal into a new proposal. Then you click OK. It's going to copy everything very quickly, and when you're ready, you'll just start drawing your roads. Now, to switch between proposals to see what you have in each one, you'll simply choose the proposal switching tool within the proposal panel or within the quick access toolbar. Both have the exact same proposals, and you can keep moving forward. Keep in mind, if you delete something in a proposal, it does not delete it in all the other proposals that item existed in. So your master conditions. This allows you to delete existing conditions objects such as dirt roads and replace them with designed roads. In the project planning phase, we created sketch roads, which were used for either a 2D or 3D representation of the road we're thinking about. However, the sketch roads, or the create roads, uses splines rather than curves and spirals. To start adding design constraints, we'll want to use the design roads, which are found on the draw toolbar in the same place, but then you use one of the design road options. The design constraints that you can add are tangent lengths, design speeds, curve and spiral radiuses, and you can actually optimize a design road, which we'll learn a little bit later. Last but not least, the design roads export out into AutoCAD Civil 3D software nicely and keep the design constraints that you create. The design roads have four different options. Freeways have a 70 mile per hour or 110 kilometers per hour maximum speed. Arterials are at 50 or 80. Collectors are at 40 to 60. And local roads are 30 miles per hour or 45 kilometers per hour maximum. When you're working with the design roads, you can set those curve and spiral settings by right-clicking and choosing either curve or spiral, curve, spiral. And when you choose the curve options, you can set that curve radius. The design speed sets the initial radius, and then you can adjust it within a certain set of parameters. You can also set the tangent lengths as you're drawing them. When you go to modify a horizontal layout of that design road, again, you'll use gizmos, and you've got the point of intersection gizmo, a midpoint gizmo, and then curve radius and point of tangency gizmos, each of them looking slightly different. Let's take a look at it. To create your design roads, you'll use the same tool that you use to create sketch roads. On the Draw toolbar, you'll go to the Create Roads tool and choose either the Design Roads Freeway, arterial, collector, or local, depending on the design speed that you require. I'm going to use my collector style, and if I need to set the style itself, I can left click twice very slowly so that then I can choose a style from the list. I happen to have my sidewalk with lamps available that I've used previously, so I'll select it. Then I start left clicking where I need the road to start. And as I move my cursor away from the beginning point, you'll notice that it's giving me the option to type in the feet. If I'd like it to be 250 units for that tangent, I type 250 and then left click, and it will create that tangent 250 units away from where I began. If I had a curve radius that was available, it would actually give me a curve. It looks as though my first tangent was too short for this one. So I'll simply type in the number of feet that I want for the next tangent. So I'm going to type in 900 and left click to accept it. And again, as I get far enough away, it should give me the option for a curve or spiral. When I right click, I can choose, instead of spiral, curve, spiral, I can choose curve, and I can right click again to set my curve options. Using the slider or putting my cursor in the curve radius to type in the radius that I desire. Then I simply left click in the model to accept it. Continuing along until I am done with the road that I wish to create, at which point I will right click and choose End Draw to end my road, or I can double click. Once my road is drawn, I can easily modify that road with the horizontal grips using either a control point for the intersection, the midpoint of my tangent, or either of the curve options, this one being the curve radius and this one being the point of tangency. If I right click on my curve, I can choose Edit Curve and change the curve radius with the slider yet again, or by typing it into the box. Design roads are different from create roads in the fact that you can add points of vertical intersection anywhere along the road that it's required, rather than just at the points of intersection horizontally. You'll use the profile view to decide how to set those. You can right click in there and set a point of intersection anywhere you wish. You can click on any of the design parameters, such as the slope, to change it within the profile view, and many other things. We'll take a look at it in just a moment. One thing to realize, though, is when you're working with the vertical of the road, you can change the vertical using gizmos in the plan view or in the profile view. When you're in the plan view, you can see the vertical gizmos that are on the left-hand side, those are all for the plan view. And then when you're in the profile view, you only have two options. You can set the point of vertical intersection, or you can set the point of vertical tangency. When I'm ready to start working in the vertical, I can left-click with my mouse and drag it to a vertical view. And as soon as I get past 45 degrees, you'll notice that my gizmos will change from horizontal gizmos to vertical gizmos. Then I simply right-click on any of those vertical gizmos and tell it to show it in the profile view. This will open up the profile view where I can modify the profile using the gizmos in the profile view or the gizmos in the model view. If I'd like to add a PVI, I can do it in either the model view or the profile view by right-clicking at the point I want to add that PVI and select Add PVI. Then I make any changes that are necessary by changing where it falls vertically and horizontally in the profile view, or if I zoom in, you'll notice that when I grab a control grip gizmo, I can only change it vertically or horizontally, but not both directions in the model view. If I would like to see the curve parameters in the model view, I'll simply right-click on that vertical curve and select Curve Properties. This will allow me to see the properties, but it does not allow me to change any of the properties. Vertical optimization is used to automatically compare costs and environmental impacts on multiple vertical designs. Once the rough horizontal and vertical design geometry has been drawn in the model, vertical optimization can be calculated to produce multiple vertical design options based on parameters that you enter into the calculator. For instance, you can add the local construction costs into the software, then you can optimize the road and figure out how much it will cost for each of the different design options, minimizing the cut and fill while also minimizing the cost. When you run the vertical optimization for relevant scenarios, you can set constraints like the maximum grade, the minimum tangent length, the drainage grade. You can anchor different PVIs. For instance, if you need to keep a certain elevation at an intersecting road, you can anchor that PVI so that it doesn't move. And you can locate borrow and waste pits to minimize the mass haul costs. Accessing the vertical optimization tools is as easy as going to the Optimize tab. Setting up the construction and earthwork costs allows you to enter the values for the excavation, load, haul, and other items that you'll be paying. Then when you're ready, you simply click on the vertical optimization and check it in the job monitor to find out how it's doing. Next, you'll want to identify the relevant project constraints so that when you've run multiple vertical optimizations, you can compare the reports and decide which report is going to give you the best alternative. Logging into the Autodesk InfraWorks 360 Job Monitor will allow you to see the optimization jobs that have been submitted. The track ID, type, and status columns indicate which jobs have completed, which had errors, and which ones are still processing. The submit time and end time columns are helpful in estimating how long the job should take according to the length of time required for other long jobs of the same size. The report column provides access to the PDF report on completion of the job processing. This report will help you select the optimum proposal based on a numeric analysis. It will actually give you a display of what that optimal proposal should look like. Then you can use the option to import that proposal, and it will create a brand new proposal inside the InfraWorks model to show you that optimized road. There are other types of spatial analysis that can help you identify issues that might potentially require attention in detailed design at an early time in the process. This enables you to either avoid the issues by selecting another design or be more aware of them at the beginning. Distance measurements help you to understand the spacing between features in the model to help you calculate rough project costs. The point-to-point option is used to measure length, width, and height from one point to another along a straight line. The polyline path is used to measure the length, width, and height along a polyline path, and the display it displays it in the model like a series of dimensions with values for each segment as well as the total distance. The rangefinder option is used to measure the distance of a target point from your current position. The distance displays in the model like a single point with a label indicating the distance, the altitude, heading, and inclination from your position. Another option is to actually do some terrain statistics. Terrain statistics are used to measure the area and volume of a terrain by specifying the perimeter points. You can also theme the terrain by doing a slope analysis, an elevation analysis, or an aspect analysis. Another option is to theme the model by features, and this will help you visualize specific aspects about them. A road layer can be themed to display the different classifications of roads, while a parcel layer can be themed to clearly indicate which properties are too expensive for the project budget and should be avoided. You'll access the measurement tools on the tool strip. By clicking the triangle, we'll find the point-to-point measurement, polyline path, rangefinder, and terrain statistics. To use the point-to-point, I simply select the tool and pick 2 points to measure the distance between them. Using the polyline path, I simply pick a point, pick a segment along that polyline. It will measure the first segment. Moving to the next point on the segment, it will measure that segment and give me the total length of the polyline as I go. When I'm done, I simply double-click to end the polyline. When I'm ready for my rangefinder, I click on it and pick a point in the model. Whatever piece of the model or whatever object in the model I pick, that's what it will measure from my current point of view. It will give me my distance, altitude, heading, and inclination to that point. Then to do my terrain statistics, I simply select points in a polygon, and it will give me the perimeter of that polygon as I go, as well as the area inside. When I have the polygon I want, I double click and it will give me my total length, area in 2D and 3D, and my volumes, cut, fill, and net. Last but not least, you may want to create some themes within the model. You do this by going to the Analyze tab, and on the Themes panel, we can choose the terrain themes or feature themes. When I choose terrain themes, the panel will become available. I simply click the plus symbol, choose the theme name, the analysis type, the minimum and maximum values, and the number of rules I need. Then I click OK, and my surface will be themed accordingly. Visual analysis tools like using a snapshot or rendering can help you understand what that model will look like much easier. When I'm ready to visualize the model and show pictures of it from certain perspectives, I want to zoom in from that perspective, then go to the Present tab, and on the Imagery panel, I'll choose either a snapshot or render. The snapshot will give me exactly what I see, but the render will make it more picturesque. Storyboards are used to communicate the design to key stakeholders. You can create slideshows and walkthroughs to let people know what that design will look like when it's complete. In doing so, you can add captions to help people understand key points of the slide presentation, and then you can export that information out to a video and put it on the web. To access the storyboards, we go to the Present tab, then on the Storytelling panel, we click Storyboards. This will open the Storyboards panel. You can see I have a number of storyboards already created, but I am going to create a new one, so I'll click Add New Storyboard, and you can see it added a third storyboard. Next, I'll need to add some paths to that. I do have the option to add camera paths by importing a camera path or creating one from a design road. If I choose the Create from Design Road option, it will ask me to select the design road in the model, so I'll select this design road, and then it will go through and take snapshots along the road down the center line. Next thing you might want to do is add additional animations. The crane animation will actually pick up from where you are and move around. You can add additional options such as the look around animation, the orbit animation, record a walk, add still motions, add track animations, and zoom animations. And you'll notice that as I add animations, the panel on the right gives me the option to actually change the parameters as I go. I can have it angle to the left 45 degrees and angle up or down 10 degrees or 15 degrees. Then when I'm ready to see what it looks like, I place my cursor where I want it to start in the captions, and I hit play, and it will go and show me each of the animations. If I'd like to start all the way at the beginning, I just move my slider bar to the beginning, place my cursor at the beginning, and hit play, and it will show me the entire animation from beginning to end. I can also import animations by choosing the option to import existing storyboards. I select it, I go out and find my storyboard, and once it's imported, I go to that storyboard and I select play, and it will go through and play my animation. The Autodesk InfraWorks design roads can be imported into the AutoCAD Civil 3D software to save time in recreating the alignments and profiles for the detailed design phase. To export the model, you'll go into InfraWorks, expand the application menu, and select Export, and select the IMX file option. Then you have the option to use a bounding box or a polygon to isolate the part of the model that you wish to share. With the model ready for the detailed design, we'll then go to the application menu, down to Export, and select Export IMX. We do have the option to do a bounding box or a polygon, or we can select the entire model. Selecting the entire model will take everything, including the existing conditions information that comes from those GIS coverages. We'll set the target coordinate system and the user file where you want it to go. So I'm going to tell it where to place it and select my polygon option, so that then I can go in and isolate as much of the model as possible, making sure that I grab as few of the GIS coverages or sketch roads as I can. When I'm done creating the polygon, I double-click the last segment of it. Then I'll click Export and tell it to replace any files that are already existing and let it export out. Now I'm ready to go into Civil 3D to work on the detailed design. When the preliminary design is done, we move into the detailed design, where we'll import the IMX file from Autodesk InfraWorks into AutoCAD Civil 3D software. Next, you'll construct an assembly based on project requirements, create the initial corridor, calculate superelevations, enhance the corridor with regions and targets, as well as intersections, then edit the corridor using Corridor Section Editor, modify a corridor using grip edits, create the finished ground corridor surface, sample it to calculate your cut and fill and material volumes, then combine the data from AutoCAD Civil 3D software in the Autodesk Navisworks software and perform a clash detection between Revit items and Civil 3D items. First thing you do in the detailed design is import that IMX file into AutoCAD Civil 3D software so you don't have to recreate the wheel when working with the alignments and profiles you've already designed in Autodesk InfraWorks. To import that IMX file, you go to the Insert tab, choose Import IMX, select the file, and allow it to import. Once the alignments and profiles are ported over from Autodesk InfraWorks into Civil 3D, you'll want to check the alignment properties. Key things you want to look for are on the Design Criteria page. You'll want to make sure that the design speed is set and the design criteria is set up so that it has the proper superelevation information calculating. Next, you'll create the assembly. with the correct assembly type. The road types and assembly types have different ways that they enact the superelevation. So you've got the undivided crowned road, the undivided planar road, divided crowned with median, and a divided planar with median. And each of those types of roads will act differently in the superelevation condition. To check the alignment properties, you'll select the alignment and then on the contextual ribbon, choose Alignment Properties. On the Design Criteria tab, you'll make sure you have a design speed and that you are using design criteria files that help you calculate the superelevation and set the maximum superelevation grade. Next, you'll select the alignment again, and on the contextual ribbon Modify tab, you'll click Superelevation and calculate or edit the superelevation. You can see the status of mine is already calculated, but if I wanted to recalculate it, I could go into the superelevation wizard, tell it to calculate it for the entire alignment. It will tell me that it's going to override the existing information. I'll click OK, and then I'll tell it the type of roadway that I have, clicking Next, telling it the number of lanes on each side, click Next, tell it a little bit about my shoulder control, hit Next, and then my attainment. Where is it taking that information? Because I had my criteria set, it's pulling it from that criteria table. When I'm done, I simply hit Finish, and it calculates that information. It will show it to me in a tabular editor so that I can go in and manually change any of the information as required. Then you'll construct an assembly based on the project requirements. The assembly is a typical cross-section of the road. The assembly marker itself is where the cross-section will apply itself horizontally and vertically to that alignment and profile. To access this, you go to the Home tab, Create Design Panel, and expand Assembly and choose Create Assembly. To create an assembly, you can call up the tool palettes with Control-C and use any of the common assemblies that are already predefined for you, or you can go to the Home tab, Create Design Panel, select Assembly, and choose Create Assembly, placing a marker in the drawing, and then using any of the predefined sub-assemblies to attach it to it. When you're done, you should have a nice assembly as you see on my screen. After you have the alignment, the profile, and the assembly, then you can create the initial corridor. You can also enhance that corridor right away by adding additional baselines and regions and setting targets. Multiple baselines will allow you to add on and off ramps or intersection modeling for things such as the turn lanes of an intersection. Adding regions allows you to show different assemblies at different points along a corridor. For instance, you might have a 4-lane highway in one region and then have a bridge region separate. To create the initial corridor, you'll go to the Home tab, Create Design Panel, and click Corridor. Then you'll give it a name, a description, an alignment, profile, and assembly. Target surface to have it daylight to any existing ground surfaces, and to edit the regions and targets initially, you can set baseline and region parameters at the get-go. Click OK, and you'll see the region and parameters dialog box. Here you can add additional baselines and profiles that go with the baseline, and then set all of your targets to all go to that existing ground surface. You can continue to enhance the corridor by adding intersections as well. Intersection modeling is a 3-step process. You'll start with general settings, where you set the name, the style, and whether or not all crowns are maintained or the primary road is only maintained. Then you'll set the geometry details and set up the corridor regions with the appropriate assemblies. Before I create an intersection, I like to zoom in on the area that has 2 alignments that intersect. Then I go to the Home tab, Create Design Panel, and choose Intersections. Selecting the top option gives me the basic intersection, and this will open up a wizard after I select the intersection of the 2 alignments. It's also going to ask me which road will be my primary, and it will define how I set the priority of my road. Then I choose whether or not the primary road is maintained or if all crowns are maintained. I click Next. I can choose which profiles to use and the priority of those profiles, which elevations will be the priority. Then I can set the offset parameters, choosing the lane widths and whether or not I have turn lanes, and the curb return parameters, deciding how the curb return will look. And I can also set the profile parameters for that lane slope and the curb return slopes. Clicking Next allows me to set all my assemblies for the corridor model, and then I simply hit Create Intersection. After you create the corridor, you can modify the corridor using grip edits or using any of the tools in the Modify Regions or Modify Corridors panel after selecting the corridor itself. When you're using the grips, the diamond grip will allow you to change 2 regions at the same time, whereas the triangle grip allows you to adjust the stationing of 1 region at a time. Additional edits can be done to the corridor using the Corridor Section Viewer. In doing so, you can go from station to station in the viewer and change specific parameters at a specific station or at a range of stations to quickly edit the corridor without having to go in and edit or create additional assemblies. When you select a corridor, you can create a finished ground corridor surface from the contextual ribbon. There are 2 types of data that you can add to that surface, whether it be the links, which is the most common, or feature lines. Once you add the information, you do need to make sure that you correct for overhang corrections. For instance, for the datum, if you need to create calculations, you'll want to correct the datum to make sure that it follows the bottom of that corridor model at all times rather than zigzag up to the top as you see in the bottom image. To create that corridor correction, you'll choose the overhang corrections for either the top or bottom links. Creating sample lines are important for when you're ready to calculate cut and fill volumes as well as material volumes and mass haul volumes. To do a sample line, you must go to the Home tab, Profile and Section Views panel and select sample lines. Then you can create them at specific stations, at a range of stations, or from corridor stations. You can calculate cut and fill volumes using the finished ground and existing ground. You can calculate both the earthwork volumes and the mass haul volumes. Then you can also calculate your material list so that you can figure out project costs associated with the different types of materials being used. You can reach a new level of communication among all the project team members by using Autodesk Navisworks Manage software. Doing so, you'll be allowed to open files directly inside of Navisworks and append additional files to them. So I can bring my Civil 3D corridors in, as well as my pipes and other items. Then I can also bring my Revit file in to see bridge structures, buildings, and other such items. In doing so, I need to make sure that the file units all match, and if they don't, I'll do some unit and transformations. Once all of the files are combined inside of Autodesk Navisworks Manage, you can then perform a clash detection. To do so, you go to the Home tab, Tools panel, and select Clash Detective. Then you can run clashes on surfaces, lines, and points to make sure that you don't have things that are occupying the same space, such as in a hard clash, or you have things that are within a certain clearance of each other for the clearance type. To do a clash detection, I start by opening an AutoCAD Civil 3D drawing, appending a Revit file to it by using the Home tab Project Panel Append option. Then I choose Clash Detective to run the clash detection. I'll need to first add a test, tell it exactly what I want to test, so I can choose specific layers or specific items in the standard drawing, and then in selection B I can run it against any specific layer. For instance, I might run my pipes and then run my test. It will tell me when it's done how many clashes I have, and then I can go review them. The final step in any project is visual communication, whether you're printing sheets for the contractors to build the project with, or taking the design from Civil 3D back into InfraWorks to update storyboards and images for the stakeholders to visually see how that project will look when it's done. When importing the AutoCAD Civil 3D road design into Autodesk Navisworks, you have a few different options on how you want to see that corridor. You can use the corridor regions instead of the native road styles, which is shown on the top left picture, or you can use the corridor regions instead of the top surface, as shown on the bottom right picture. If you do not select either of those options upon importing it, you will end up using the native road styles from InfraWorks to show the corridor as shown on the bottom left image. A scenario is a package of saved storyboards, points of interest, and watermarks from the Autodesk InfraWorks model. Use scenarios to share all or part of a model with the general public. You can do this by publishing the storyboard to a website or to iTunes, or you can use an Autodesk 360 group to limit users to a set of reviewers that you define. If you'd like a list of all the objectives that we covered today, you can download an exam roadmap from the class materials. If you'd like additional information on any of the subjects that we talked about, you can visit ascented.com to purchase your copy of the Autodesk Infrastructure Design Suite BIM Workflow for Roads and Highways Student Guide. Just to briefly show you what is in that guide, you'll notice that the exam objectives are listed in the left margin of the sections that have to do with any of the exam objectives. I really like the command summaries that are also listed at the end of each chapter because they're a quick reference to any of the commands utilized in that chapter. And to reinforce learning, there are both practice exercises and chapter review questions so that you can review everything you've learned and make sure you grasp it and understand it. I definitely want to thank you today for watching this video, and please send your feedback to let me know what you thought of this exam prep class. You can send your questions and comments to mrasmussen@rand.com.